verify that f and g are inverse functions. So let's look at given two functions. So fx equal to negative 5 over 2x minus 3 and gx equals to negative 2x plus 6 over 5. Okay, so we have many different methods to verify two functions are inverse functions of each other. So this lesson video, I'm going to introduce two different methods. One is the using one function and find the inverse function. The other one using composition function property. Okay, so the first method using the one of the functions. So it is up to you which one you choose, but I will choose for this lesson fx here. So from fx, I'm going to make y equal to negative 5 over 2x minus 3. And from here, we switch x and g position. So that's the first step to find the inverse functions, right? So then this becomes x equal to negative 5 over 2y minus 3 here. And from here, you are solving for y. Therefore, I'm going to combine, add 3 first. Then this becomes x plus 3 equal to negative 5 over 2y. And then multiply everything negative 2 over 5, which is reciprocal of y coefficient. Then this cancelled out, and negative become positive. So then y equal to negative 2x plus 3 over 5. Okay, therefore we can rewrite f inverse equal to negative 2 x plus 3 over 5. Now just compare given gx and then f prime x here. It looks a little bit different though, so I'm gonna match the format. Then now take out negative outside, then become and then distribute. So 2x plus 6 over 5. So as you see, this is exactly same as this one. Therefore, we found fx and gx are inverse functions with each other. Okay, another method, we can use composition function, which means we plug one function into another function. So let me copy the original fx and gx one more time, and then we want to find out one of them's composition function here. So we found f and g are inverse functions already, right? Okay, then let's go back to previous lesson and then find out any inverse function case here. So let me use this function. So fx is x minus 4, f prime x equal to x plus 4 here, right? I'm using this to function and then find out their composition function here. So key point is fx equal to x minus 4, f prime x equal to x plus 4. Let's find out f open dot f prime x, which means you are plugging this into here basically, right? Then this becomes x plus 4 minus 4. Therefore x plus 4 minus 4, so answer becomes x. What about we find f inverse open dot fx. Then it become x minus 4 plus 4. So x minus 4 plus 4, so equal to x again. So from here we can find out if two functions are inverse function, if we find out their composition function, the answer always come out x here. Using this property, we can double check. Just go back to our original function. Let's find their composition function. So I'm gonna find out f open dot gx. Okay, then you are plugging gx value into here. Then this becomes negative 5 over 2, and then negative 2x plus 6 over 5 minus 3. Okay, so open the parentheses, which means distribute. So negative and negative become positive, and then this becomes, so 10x plus 30 over 2 times 5 become 10 minus 3, which means x plus 3 minus 3, so become x. As you see, we got x here, so they are inverse function. Let's try to find out g open the fx again. So g open dot fx, which means you are plugging fx into gx right here. So this becomes negative 2 times negative 5 over 2 x minus 3. So plus 6 over 5, right? Okay, then this becomes distribute, then negative become positive, and then 2 and 2 cancel out, so become 5x, and then becomes, so negative stay outside, and then take 5x, and then become minus 6 and plus 6 over 5, and it is cancelled out to become negative 5x over 5. And then this case, now, before it was minus 5x, by the way, so become plus 5x over 5, so become x here. So as you see, either f open the gx or g open the fx, we both got x here. Therefore, we can also verify f and g are inverse function with each other.